Okay. Good evening, everybody. Good evening, students. Once again, I am with you with a new topic called as hyperconjugation. I hope. Good evening, everyone. Once again, we are here with a new topic called as hyperconjugation, and I hope that you must have heard about hyperconjugation a little bit. I'll assist you in knowing the details about this hyperconjugation, and this is one of the very important principles of organic chemistry with which we explain a variety of things. But unless and until we know about the concept in detail, it will be difficult for us to apply it to various situations. So I am moving ahead with whatever is there in hyperconjugation and whatever you need to know in hyperconjugation. I have elaborated my theory with a couple of questions which again should be treated as a theory so that you can apply it in various situations. And before we start, we should have a firm conviction that we are going to be a master of this topic. That is what my belief is. Right? Are you ready with Altedemy? Okay. And before we go ahead, I would like to know about the quality of broadcast on the scale of 1 to 10 as we ask it as usual. Are you finding it good or up to your satisfaction? You can rate us in between 1 to 10. And secondly, we would like to ask about your state of preparation of the examination on the scale of 1 to 3. You should press 3 if you're feeling that your preparation is very good. Otherwise, you can press the button of your choice. Okay. I should tell a little bit about myself. My name is Vishwajeet Poddar. I am a graduate and postgraduate from University of Delhi, and I am associated with this teaching profession for past 15 years, and I have taught in many of the organizations in the city. Naming some of them is Vidya Mandir classes, Sri Chaitanya and Narayana institutes, and I have helped many students to clear their examination, that is NEET examination. Okay. Coming to the concept of hyperconjugation, how should you visualize it? Hyperconjugation. Okay, let me begin with a small notion or a small concept that you might have come across. If I ask you, here we have a benzene ring, right? And with this benzene ring, there is a group that is attached, that is CH3. Okay. Now, as we know about various groups which are associated with benzene ring, they are electron donating group, and those electron donating group are called as ortho para director. You might have known about it, or you might know about it. And there are electron withdrawing group which are meta director. These are the things that you probably know. Now, where do you place CH3? Will it be ortho para director or it will be a meta director? You may say that CH3 is electron donating a group, an electron donating group, and that is why it is ortho para director, which is a correct version. Now we should know how it is an ortho para director. What happens when CH3 is associated or it is attached with benzene ring? What happens so that the electron, the concentration of electrons come at this place, and this place? These are ortho and para place. For understanding this, you will have to look into the structure from this place to this place. It can as well be, written as C double bond C, and then CH3 is associated with it. This is a primary essential prerequisite for hyperconjugation to take place. Now look, you should understand the things. Rotation around a sigma bond is possible, but rotation around a pi bond is not possible. Here we call this as sigma electrons, and here we have Sp2 hybridization. As we know that C double bond will be having Sp2 hybridization. So you can generally understand there is a pure p orbital which is lying perpendicular to this plane. Now this CH3, all these things are rotating because this sigma bond is there. It is rotating and rotating with a very high speed, whereas these p orbitals, they are fixed. These p orbital have got one electron also. Bear in mind, if there is sp2 hybridization, that means 1s and 2p, they are involved having one electron, and there is one p which is vacant. Vacant in the sense there is one electron lying unoccupied or unshared. Now when there is a fast rotation into this, in turn what is happening? These electrons intermingle, and these electron intermingle, leading to there is a no bond situation like this. This bond will be coming to this place, and this bond will be displaced from this place to this place, leading to a negative charge at this place. Same is the case, that is what is happening here. When CH3 is attached with a benzene ring, we get a negative charge at ortho position, and again it undergoes resonance, and at the para position again the negative charge will be coming. So this is how things will be happening. So we can say it is one of the very important electronic effects because of which we try to understand about delocalization of electrons leading to various kinds, right? It is the phenomenon that is always taking place. We need to understand that the delocalization of a sigma bond which is adjacent to a pi bond is called as hyperconjugation, as I have explained you. And it is shown by highly polar bonds. Bonds have to be polar, then only this thing will take place. Okay. Look, if we take CH or CX bond, like we are taking here, let me change the color. We are taking CH bond, or we take CX bond. X is what? X is a halogen. X is a halogen, hydrogen is a hydrogen. There is a sigma bond. Well, we call this as a sigma bond. The sign of this is sigma bond. Again, this is also there, and we call this as a sigma bond, right? And if it is adjacent to a double bond situation, situation is conducive for hyperconjugation. And you can generally say that in hyperconjugation, what basically is happening? A sigma bond is interacting with a p orbital. This is how we define it very correctly. A sigma bond interacts with a p orbital. Well, which are the substances which will show hyperconjugation? We need CH3 or CX3 type situation. They will show this, right? And we have shown about the compounds also, like CH3, CH, double bond CH2. If we have a compound like this, it will show hyperconjugation. Even if we have CX3, CH, double bond CH2, this will also show hyperconjugation. X stands for halogen. X is halogen. This will also be showing hyperconjugation, but in a different direction. Later we will come to know it is creating plus H effect and minus H effect. As I have told you earlier, plus is always push minus is always pull, plus push minus pull. So first we are trying to understand where hyperconjugation will come up. If it is a straight compound, then this should be a situation. Allylic, you can say allylic situation is there. CC double bond should be there. Adjacent to that, there should be alpha carbon, and along with alpha carbon, we have alpha hydrogen. Okay, moving ahead. Again, what is happening? The sigma bond is getting delocalized as this is the situation. CH3, CH double bond, CH2. In turn, what is happening that I have shown here? What will happen to these various compounds? Look, this carbon has got 3 hydrogen attached with it. And one after another, all these hydrogen will be undergoing this kind of situation. It is a situation that we called as no bond resonance. It is a type of effect we associated generally with resonance. However, the intensity of effect of hyperconjugation is much less than that of resonance. So this sigma bond gets delocalized and there is sp3p overlap. sp3p overlap that is going on. One after another. First this H, the bond gets broken in a fashion. You should not understand that the bond has been broken and here this compound is having an H plus, so it has become acidic. No, it has not to be thought like that. This H gets dissociated, but it does not move away from this place. You will have to understand this particular situation, that when this kind of hyperconjugation is taking place, because of a high speed movement, high speed rotation around sigma bond, the delocalization takes place, and this delocalization results into no bond situation. But this no bond cannot be understood that it has completely been dissociated. That's why it is being shown as a dotted line. It has been dissociated, but still it is attached. So all these hydrogen will be showing such kind of situation, and there will be a negative charge here that will be coming. Now, more the number of hyperconjugative structure, more will be the stability, as we find in the case of resonance. If a compound is forming more number of resonating structure, we understand or we perceive that more is the stability. Same actually is the case. More the number of hyperconjugative structure, more will be the situation. We have to bear in mind that what is the essential condition? There should be a pure p orbital. Pure p orbital that should be present in any situation for hyperconjugation to occur. We will see another situations also, orbital concepts also. Hyperconjugation effect is a permanent effect in which localization of sigma electrons of CH bond of its delocalization, I beg your pardon, directly attached to an atom of the unsaturated system or to an atom with an unshared p orbital takes place. Look, what are the structural requirements for hyperconjugation? The structural requirement for hyperconjugation is the compound should have at least one sp2 hybrid carbon of either alkene or alkyl carbocation or alkyl free radical. In all these situations, in case of alkene, in case of an alkyl carbocation, carbon with a positive charge, and even in case of free radical, we can generally understand that hyperconjugation will take place. The alpha carbon with respect to sp2 hybrid carbon should have at least one hydrogen. At the alpha position, at least there should be one hydrogen which can be delocalized or which can participate in a no bond situation. Okay, again, we can see it diagrammatically, and to clarify our concept a little bit further, look here how hyperconjugation is taking place. Here we had CH3, there were 3 H, and here we had carbon with a positive charge. Well, carbon with a positive charge. In normal situation, this is sp2 hybridized. And when it is sp2 hybridized, obviously there will be empty 2p orbital of carbon will be present. Empty 2p orbital of carbon will be present. Now, when they are in proximity, and this is basically a situation when they come in proximity, electrons are moving. For this CH3, electrons are moving with high speed, and because of this movement, this kind of delocalization takes place. There will be an interaction between pure p orbital, which is a static, and this moving CH bonds, which is sigma bond. So this is the situation that is happening. We have taken up a couple of compounds here. Like here we have trimethyl carbocation, dimethyl carbocation, ethyl carbocation, and this is CH3 plus. We should write here CH3 plus. From the given figure with that we observed that one of the three CH bonds of the methyl group can align in the plane of the empty p orbital, can align. How will it align? When it is rotating, then only it will align. It is continuously rotating, and I told you rotation around a sigma bond is possible. So it is when it comes in the plane of the empty p orbital, and the electrons constituting the CH bond in a plane with this p orbital can then be delocalized into the empty p orbital. This is very important. If somebody will be asking why it is happening, it is happening because of this rotation. CH3 sigma rotation is taking place. We also observe that the hyperconjugation stabilizes the carbocation as it helps in the dispersal of positive charges. Well, with this carbocation, when hyperconjugation is taking place, it is stabilizing the carbocation. Thus, we can say that the greater the number of alkyl groups attached to a positively charged carbon atom, the greater is the hyperconjugation, interaction and stabilization of the carbocation. The relative stability on the basis of hyperconjugation is given as you can see how it is stabilized. I will explain you further how it is being stabilized. More of hyperconjugation, more is the stability. And before we move ahead, let me tell you about Altedemy classes. We have our courses where we provide 90 plus classes. We have a convenient educational platform. The syllabus that we are providing, it is from the NEET experts. We have a flipped classroom method about which I have discussed, but I'll show you once again. And we have the practice of doubt solving. You should participate into it. This is what our class looks like. When you will be joining our classes, what are the things that you will be getting? One thing is whenever a chapter is being taught or chapter is being discussed, prior to that a theory is given to you. Along with our discussions, the study material goes to you, which generally is in the form of our discussion. We conduct webinars also, as we are conducting right now. In this webinar, you will come across a variety of things. Along with all these process, we give you homework also, where you solve plenty of questions, and we discuss those questions also. You get an analysis of those questions, and these homeworks are also being checked so that you get the score that you deserve, right? And whatever is the scope of improvement, you should definitely understand that. So my suggestion is that if you participate with us diligently, then there is no chances that you will not be getting through. You will definitely be getting through, because we are also working very hard for your success, right? Along with Altedemy. For you, we have made 3 different kinds of programs, and we call these programs as light, smart and proficient program. What are the features of these program? You should take a look. We have interactive live classes, which is common with all those light, smart and proficient programs. We have structured courses and PDFs. It is again common with all those. Live tests we conduct, where we have in all these 3 courses we do this. Physical notes that obviously you get. There is, besides these four things that we have taught, which is the you can say backbone of our classes, backbone of our discussions or classes. We also provide one-to-one mentorship. One-to-one mentorship is available with the smart and proficient courses. It is not available with light courses. In one-to-one mentorship, there will be a mentor who will be taking care of whatever questions that you come up with. We have live doubt solving problems. Live doubt solving problems are very important, because when you are studying and when you come across your theory, then suddenly you come across some kind of doubt, then there should be somebody to solve your doubt, right? We do that. We conduct mock tests regularly, and these tests are very important. Once you have studied the theory, if you take the test, then only you can judge yourself. Testing is very important. So it is in the smart program as well as in proficient program. And besides all those things, again, we have an additional special course. If somebody has studied, somebody thinks that he knows it and needs to know something on a higher scale, again, we have a provision of additional special courses. So we do in a proficient course that way. We will suggest you to go for a smart course. That is our most, a kind of program that we have built up. It doesn't burn a hole in your pocket, and you get all the benefits of Altedemy through this program. Okay, moving ahead with our own chapter, hyperconjugation. Hyperconjugation is generally viewed, and that is of three types. Here I should tell you, as I told you, there are two types of hyperconjugation. We call it plus H and minus H. Right now we are talking about plus H only. Plus H, plus is push. This hyperconjugation, it comes up in three different situations. One, sigma CH pi conjugation. As we told you, you can see here, these are different compounds that we have taken. We should have sigma CH bond. That is essential. Here you can see, here we have what? We have CH, H, H, CH, double bond CH2. So this is sigma bond and this is pi. They are in conjugation. So this situation is conducive for it. Again, here also you can understand there is one H that is involved. These will not participate. Remember, only the alpha hydrogen. What is alpha hydrogen? Alpha hydrogen is the one which is connected with alpha carbon. And what is alpha carbon? Alpha carbon which is connected in this situation with CC double bond. Right? Look at this situation. Here compound is there, but there is no alpha hydrogen. So this will not be showing hyperconjugation. This is the first situation. First variety of hyperconjugation that you will be coming across. Coming to another aspect of it, where hyperconjugation takes place, there should be sigma CH positive charge conjugation. Look here. Here we have a situation CH, H, H. And then we have CH2 with a positive charge. You can easily understand this is in the state of Sp2 hybridization. And when it is in the state of Sp2 hybridization, there has to be a p orbital perpendicular to this. You should know that carbocation is Sp2 hybridized. Carbanion is Sp3 hybridized in normal situation, right? So even this is a situation where hyperconjugation will take place. Look here. You must have heard, or you must have handled also, trimethyl carbocation. There are three methyl which are attached with this situation. It is very stable, very much stable, because three hyperconjugation from this side, three from this side, three from this side. There will be 9 hyperconjugative structure that you can form. So it's highly stable, and hyperconjugation plus H, you can understand it gives stability to carbocation. So this was the second variety of hyperconjugation. We have a third variety of hyperconjugation, that is CH and odd electron conjugation. Just try to look at it. We can talk about hyperconjugation here with a little bit of caution. Look here. Here there is a radical. Here there is a radical. Though we say that hyperconjugation will take place at this place. But what is the problem with it? Why don't we take it, or why don't we treat it seriously? Suppose hyperconjugative structures are being made. Then As a result, what will happen? We will get a hydrogen radical. And remember one point. In any chemical process, if you are forming a hydrogen radical, it is a mistake. You will know about this. I'll discuss also. It's a mistake. Mistake in the sense, hydrogen radical is very stable, very reactive. If it is very reactive, as soon as it will form, it will react with something, or the existence will not be there. So making a hydrogen radical in any situation is a risky proposition. That's why theoretically we say it will happen, but generally we do not do. You will never get a question on the basis of these radicals. If at all you will be getting a question, you will be getting a question why such kind of hyperconjugation in free radical does not hold any significance. Reason is only this. Hydrogen radical formation of hydrogen radical in any situation is not permissible, right? Okay, so we will generally not be studying much about this. Coming to our original situation, when CH sigma electrons are in conjugation to pi bond, this conjugation is known as pi CH pi conjugation, excessive conjugation or hyperconjugation. It is also called as no bond resonance because in the different canonical forms, no bond exists between carbon and hydrogen atom of the alkyl group. It is by and large one and the same thing that we are saying since the beginning of the lecture. There was a compound like CH3, CH double bond CH2. We have made different hyperconjugative structure. Here I should not have given this bond. This you should not treat this. One no bond situation here, another no bond situation here, third no bond situation here, like this. H plus will be created, but it won't be acidic that way. It won't be going anywhere. Like it should not be thought that H plus has been created, then it should behave as an acidic substance. No, nothing like that. Okay, so basically sp3s overlap is called as hyperconjugation. sp3p overlap, sp3p overlap, sp3 and there is a p overlap, sp3 and there is a p overlap. All those situations you can have, right? I hope with these diagrams matter is very much clear what basically we intend to do. As I was telling repeatedly, I have written it also. Here H plus is not completely free. All H will overlap. Which H? Alpha H. Number of hyperconjugative structure is equal to number of alpha hydrogen. As many alpha hydrogen will be present, as many hyperconjugation will be there. There is a small delocalization because of hyperconjugation less than resonance. We should understand it very clearly. The effect of, I had told you about AERHI, right? AERHI. Aromaticity equal RS, resonance, hyperconjugation and inductive effect. The effect of resonance is any time greater than that of hyperconjugation. I will show you an exception also. Wait for the time. Hyperconjugation is also called as sp3p overlap or sigma p overlap. This is the correct version, sp3p or sigma p overlap. Previously I just wrote one at one place S. No, I revised it, sp3p overlap, sigma p overlap. Okay. Hyperconjugation can also be viewed as plus H and minus H. Plus H increases electron density in a resonating structure, as we have seen in the case of CH3. Like we had this benzene ring, this is CH3, this is showing plus H effect, pushing the electron inside this carbon in this benzene ring. And just because it is pushing the electron in the benzene ring, the electron density in benzene ring gets increased. And because of that, the electrophilic substitution reaction, which is the characteristic reaction of benzene ring, it gets enhanced. So H plus H increases electron density in a resonating structure. And plus H effect works with equal effect at ortho and para position. Bear in mind, this is the ortho position, this is the para position. It works with equal effect. It won't say here it will be more, here it will be less. No, it's not a distance dependent effect. As a general rule, effect of M is mesomeric effect, is much mesomeric effect and resonance. I hope you can distinguish between the two. Anyway, you should treat this resonance for the time being. Mesomeric effect and resonance effect, there is a slight difference between the two. It is very much higher than hyperconjugation. Hyperconjugation again has got higher effect than inductive effect. Here there is a caution. Plus H effect of methyl, plus H effect of methyl is greater than plus M of phenyl. Plus H effect of methyl is greater than plus M of methyl. Plus M is a tendency again to donate the electron. Plus H again, donation, is the tendency to donate. So this is where one exception lies. Plus H of methyl is greater than plus M of phenyl. In one case, hyperconjugation becomes more powerful in comparison to mesomerism, or you can say resonance. Plus H effect increases the stability of alkenes. Very important. Whenever you will be studying alkene and you will talk about the stability of alkene, you will always follow the hyperconjugation. Like we have taken variety of compounds. Look here. We have taken a compound CH2 double bond CH2. This is the first compound. Second compound is CH3 CH double bond CH2. This is the second compound. This is the first one. This is the second one. The third one that we have taken is CH3 CH double bond CH and CH3. The fourth compound is CH3 CCH3 double bond CH CH3, and the fifth compound is CH3 CH3 double bond CH3 CH3. Now in general, if you are asked which is more stable, which is less stable, or what is the order of stability, this is the first utility of hyperconjugation that you will be seeing. Here you can see there is no alpha hydrogen. No alpha hydrogen means no hyperconjugation. Here you can see there are 3 alpha hydrogen. Here you can see there are 6 alpha hydrogen. Here you can see there are 9 alpha hydrogen. And here you can see there are 12 alpha hydrogen. More alpha hydrogen, more is the hyperconjugation. More is the hyperconjugation, more is the stability of the compound. Therefore, the stability order that we have written is 5th is greater than 4, is greater than 3, is greater than 2, is greater than 1. And it is understandable on the basis of number of alpha hydrogen. Right? Coming to other aspects also. More easily the sigma bond gets delocalized, better is extent of hyperconjugation. More easily the sigma bond gets delocalized. Now here we are taking another aspect which again is asked at times. What about these bonds? These T, D and HR, isotopes of hydrogen, hydrogen, deuterium, tritium. This is the order of bond strength. You should remember, this is the order of bond strength. If this is the order of bond strength and we are saying more easily the sigma bond gets delocalized, then it is easily understandable when there is a situation of CH3, then the bonds will be easily delocalized. And as a general rule, the extent of plus H or hyperconjugation, it can be seen with CH3 maximum, CH2D, then comes CHD2, as the weight is increasing, you can easily find out the extent of delocalization is getting reduced. See, D2T. Tritium is heavier than deuterium. Deuterium is heavier than hydrogen. So CH bond will be the lightest kind of thing. So easy delocalization. CD2T greater than CD2 greater than CT3. At times it is asked. More easily the sigma bond gets delocalized. Better is the extent of hyperconjugation. Yes, along with this, we are all talking about what? Plus H effect. But here you should bear in mind, we have already talked about positive inductive effect. The inductive effect is just in the reverse order. This we have made the order of hyperconjugation. If you will be writing the inductive effect, the order of inductive effect, obviously it will be in the reverse order. If in a situation both plus H and plus I are operating, then we will take plus H into consideration. As we have said, plus H has got higher strength, higher capacity in comparison to inductive effect. So plus H effect, next point that we are coming, plus H effect increases the stability of carbocation. Look here, we can take three examples. We have a compound called as CH3 plus, we have another compound CH3 CH2 plus, and we have yet another compound CH3 CH2 CH2 plus. Now from the point of view of this carbocation, let us try to count number of alpha hydrogen present in any of the structures. We can see there is 0 alpha hydrogen. There are 3 alpha hydrogen. And here be careful, we have nothing to do with this carbon. There are just 2 alpha hydrogen. So extent of hyperconjugation is maximum in second. So as far as the stability of these carbocations are concerned, second will be more stable in comparison to third, in comparison to first. Can you understand and can justify this? More the alpha hydrogen, more is the stability. And where we can apply it in case of alkenes, we can apply, or rather we are applying it in the case of carbocations, right? Look at the case. We have a structure like this, cyclohexane, and there this will be carbon, and here we have a carbocation here. Again, come to this, we have a positive charge at this place and the compound is this. And again, here we have a positive charge and here we have a carbon. Now, it's not a benzene ring, bear in mind. Suppose we have 1, 2, 3 structure. Can we count number of alpha hydrogen? For this positive charge, this will be the alpha carbon. So there is just 1 alpha hydrogen. Can you count it? But with this positive charge, there are 2 hydrogen here, 1 hydrogen here, there will be 3 alpha hydrogen here. And with this, here we have a positive charge. So here we have a carbon, and where 3 alpha hydrogen, 2 here and 2 here. So there are 7 alpha hydrogen here. And now it is very easy to find out which is the most stable carbocation. You can easily say third is the most stable, then comes second one, then comes the first one, right? And this way we give the stability of various carbocations. Again, we are taking a problem like the first compound is CH3 CH plus CH3. This is the first compound. The other compound is CD3 CH plus CH3. Now, this is the first structure and this is the second structure. Extent of hyperconjugation. Here we have just put D. So the delocalization of this will be difficult. So the extent of hyperconjugation will be less, right? So here we can easily understand that first structure has more extent of hyperconjugation. So first is more stable in comparison to second as far as stability is concerned. I hope you do not have any problem in understanding, keeping in view that the theory that we have explained is self-explanatory. All these questions should be treated as a part of the theory. Again, we are taking another problem. We have a compound like C, CH3, 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 C, CH3, CH3, CH3. At times, CH3 is written as Me, methyl. C2H5 is written as ET, ethyl. Propyl, PROP, prop, it will be written. Sometimes it is done just to create a little bit of confusion in your mind. CH3, CH3, CH. And here we have a positive. Now, can you let me know whether it will be having any hyperconjugative structure? It will not be having any hyperconjugative structure. There is no alpha hydrogen that is present. But on the contrary, if you take CH3, 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 and here if we have a carbocation, then obviously it has 9 alpha hydrogen. So if you compare these two carbocations, if you call this as second, if you call this as first, then second obviously is more stable than the first, right? I hope you will be in a position to do these questions very clearly. Okay. If we are taking any state of carbon ion, carbon with a negative charge, like we have taken suppose a situation CH3, CH double bond, CH2 with a negative charge. This is a case of carbon ion. In the case of carbon ion, no hyperconjugation. Why no hyperconjugation? Why no hyperconjugation? Because there is no empty p orbital with this carbon. We need pure p orbital. We need pure p orbital, right? So there won't be any hyperconjugation with this. And hyperconjugation is not important in free radicals. I explained you about that, why it is not important, right? And it should be quoted like this. But look at this structure. Look at this structure. This structure should be treated as an exceptional structure. And this is counted as an exception. This is one carbon ion. Here we have a negative charge here. This will use hyperconjugation. Here plus H will be taken because CH2 minus is Sp2 hybridized. Bear in mind, it is very important. Whenever there is a negative charge which is in conjugation with a double bond, normally what do we do? Like suppose we have CH3, CH, CH2 with a negative charge. We say it is Sp3 hybridized. But if it is a situation like CH2 double bond CH, CH2 with a negative charge, suppose this is a situation, then this is no more Sp3. This is no more Sp3. No more Sp3. Because this negative charge will be delocalized. This negative charge will be delocalized. So you cannot count for this carbon. So there will be 6 carbon and it will be Sp2 hybridized instead. It will be Sp2. And if it will be Sp2 hybridized, obviously pure p orbital will be present. So this is a situation where plus H effect will be there, and this plus H effect will be pushing the electron, and it will be making it unstable. Remember, this is being unstabilized by the plus H effect of this group, because CH3 is an electron pushing. It's create plus H effect. So it will be pushing electron. Further concentration of electron will be. So it will be unstable. If the charge is delocalized, then it causes some kind of stability. Coming to another question, look here. Minus H. Let us talk. We have talked enough about plus H effect. Let us talk a little bit about minus H effect. Minus H effect is shown by minus CX3. Look here, we have explained here. CX3, X is halogen. If CX3 is attached to a conjugated system, it will show minus H effect. Now here, instead of pushing, it will be pulling. And you should bear in mind, suppose with a benzene ring, you put, let us say, CCl3, and you are asked whether it will be ortho para director or meta director. Then obviously you should say it will be meta director. Why it will be meta director? Because it will be electron withdrawing a group. And electron withdrawing, why it will be electron withdrawing? Because of minus H effect. Now the electrons are being pulled out. Electrons are being pulled out. Minus H effect also work with equal strength at ortho and at para position. At ortho and para position, there it creates deficiency of electron. Plus H effect creates surplus of electron at ortho and para position. Minus H effect creates a deficiency of electron at ortho and para position, and does it equally. That is why we have written minus H effect also works with equal strength at ortho and para position and absent at meta position. Look here, bond strength, as we know, we have CF bond greater than CCl bond, greater than CBr bond, and greater than Ci bond. We have the bond strength. Why the bond strength is like that? Because of the size. CF size is small, like this. So order of minus H effect, order of minus H effect, the bond where it is weak, the delocalization is easy. So obviously we can say minus H effect are in the order Ci3, CBr3, CCl3, and CF3. And as a matter of fact, we should know certain things. Only CCl3 show minus H effect, which actually should be called as significant. Others do not show minus H effect practically. I have written it plainly, but practically minus H is shown only by CCl3 and to some extent by CBr3, minus H effect. And if you compare minus H with minus I effect is just opposite to minus H effect. As plus H was opposite to plus I, minus H is just opposite to minus I. There is no minus H effect on carbocation, no minus H effect on radical also. As there was no plus H effect in carbanion, similarly, no minus H effect on carbocation and no minus H effect on radical also. But yes, minus H effect can be taken if compound is conjugated. Here you can generally see that minus H effect can be seen here, because you can easily understand if it is minus CH2, then you can say it is Sp2 hybridized. And if it is Sp2 hybridized, then obviously pure p orbitals will be present out there, right? Okay. Let us solve a question. Suppose you have been given these two compounds where phenol is there, and with phenol in first case CH3 is attached, in another case with phenol CD3 is attached. Now, which is more acidic? Look, when a phenol is acidic or shows its acidic behavior, what it does, we can easily understand that there will be a phenoxide ion and it will be losing one H plus. Now, we will talk about the stability of this phenoxide ion. What do you think? if there is a oxygen present here and there is a negative charge, if in one case we are putting CH3, in another case we are putting CD3, in which case this phenoxide ion will be more stable, and the more stable substance on the other hand will be giving us more acidic substance. Look, plus HF of CH3 is more than plus H of CD3, that we have understood. Plus H. So what CH3 will be doing, CH3 is showing plus H effect. This is also showing plus H effect. But plus H of CH3 is greater than plus H of CD3. So CD3 will be pushing the electron less. If it is pushing the electron less, then the stability of this particular phenoxide ion will be more. If this will be having more stability, then we can generally say that the second compound will be more acidic, because after showing acidic effect, it will be a more stable a compound. I hope you got the point. Let us try another question. Now again we have phenol, but now CH3 is at meta position and CD3 is again at meta position. Now when it is at meta position, we cannot apply hyperconjugation. Hyperconjugation can be applied only when compounds are attached at ortho and para position. When they are at meta position, the only thing that is operating here is what? Inductive effect. Inductive effect. Right? We can count inductive effect. And here we can understand that one is more acidic. One is more acidic. Why one is more acidic? Because if you will see that neutralization of phenoxide ion, when CH3 is at like CH3 will be pushing the electron less in comparison to CD3. So plus I effect of CD3 is more than that of plus I of CH3. So if positive inductive effect, then obviously it will leading to less of a stability, because again a substance which is having plus I effect, it will be pushing electron, and if it will be pushing electron, then the concentration of electron will be more, leading it to less of a stability. So that is the reason that we do it. Let us take another question, which is very beautiful a question. We have 4 different structures, and before attempting this question, let us talk about stability of alkenes. We can come across 3 different kind of alkenes, and we should try to know that. We can have conjugated alkene, like this is a conjugated alkene. We have isolated alkene, like this is an isolated alkene. And we have cumulated alkene, this is cumulated alkene. This again is conjugated. This is conjugated. This is conjugated. This is isolated. And this is cumulated. You can be given different kind of alkenes. Alkenes can be conjugated, alkenes can be isolated. If more than one double bond are present in any of the compound, we can have conjugated, cumulated and isolated alkenes. Among such kind of alkenes, we have this order always. Conjugated is always more stable in comparison to isolated, and isolated is more stable in comparison to cumulated. So if we talk about stability, we can take what? Conjugated alkene first. Conjugated alkene. Which are conjugated alkene that we can say? Here it is, third is conjugated, right? Third is conjugated. Which other alkene is conjugated? Any other alkene that we find is conjugated? Here we have miss slightly. The double bond should be here. Yes, it is like this. It should be here. Anyway, I missed it. So third is a conjugated alkene, because I have given the answer as third and fourth. Third and fourth both has to be conjugated. Anyway, if you can differentiate between conjugated, isolated and cumulated, you understand. This is cumulated alkene. This is cumulated. Cumulated means there are two double bonds in the adjacent position. So this is cumulated, this is cumulated. In cumulated alkenes, you can find out first and second both are cumulated. So in first and second, second is more stable, that we are saying, because second has got 3 hyperconjugative structures. Here we have just 2 hyperconjugative structures. So 2 is more stable than 1, right? So both will be, since they will be cumulated alkene, so will be in the lesser order. Among third and fourth, if we are supposed to say, third is a conjugated, obviously third will be most stable. If we say it's an isolated one, well, isolated alkene are more stable in comparison to any cumulated. So 2 and 1 will be here only. So this is the order that has been given: cumulated, isolated, not cumulated, sorry, it is conjugated. It is conjugated, then isolated, then cumulated. If you come across any kind of alkene, you should always follow this order, which are conjugated alkene, where the double bonds are at alternative places, pi, sigma, pi situation, conjugated. Isolated means pi, sigma, sigma, pi, isolated. This double bond has got nothing to do with this double bond. No resonance. Cumulated, 2 double bond at adjacent position, they are cumulated. Coming to another question. Here we are talking about stability order. Look here. So we have the order of what? Conjugated, isolated, cumulated. 1, 2, 3, 4. Can we see 1 and 4 are conjugated? 1 and 4 are conjugated. 2 and 3 are isolated. Right? So in any case, 1 and 4 will be more stable in comparison to 3 or 2. This is something which is very clear. Now, among 1 and 4, we can say 1 has 7 alpha hydrogen. 1 has 7 alpha hydrogen. We can find it out, 7 alpha hydrogen. There is double bond here. There are 3 hydrogen present out here. Again with this, we can say 3 hydrogen here, 2 hydrogen here. With this double bond, again 2. So it has 7 alpha hydrogen. So 1 has 7 alpha hydrogen, so 1 is maximum stable. This 4 has 3 alpha hydrogen. 4 has got only 3 alpha hydrogen. Which are those 3? With this, there are 2 hydrogen attached here, 1 hydrogen here. So 3 here. Now, coming to third and second, out of 2 and 3, 2 has 3 alpha hydrogen. Second has 3 alpha hydrogen. Which are those? Here we have 2 hydrogen and here we have 1. So it has 3 alpha hydrogen. This way we can say the order is like this. Stability can be found out with this help of this. Coming across a very important question. You have to find out the acidic strength of these compounds, where we have attached with a benzoic acid CH3 at para position, at meta position, CCl3 at para position, meta position, and then we have CBr3. We should know the following things. First thing is, plus H effect decreases strength, acidic strength, like plus I. Plus I decreases acidic strength, we had studied. Now, minus H of CBr3 is greater than minus H of CCl3. We have said, we have studied about it. First has only plus H effect. This has got plus H effect. Second has only plus I effect. Third has got minus H effect. Very good. Third has got minus H. So minus H effect will be doing something for acidity. Fourth also has got minus H effect. and fifth again has got minus I effect. Minus H effect will be working at ortho and para position only. So those positions where at para position things are attached, there we have set minus H effect or plus H effect, right? First CH3 gives a plus H effect. CCl3 or CBr3 gives minus H effect. Okay. So minus H effect will be increasing the acidic strength. So we have kept 4. 4 means what? CBr3, because the minus H effect of CBr3 is greater than minus H of CCl3. We have read it just now, right? So the order is fourth will be maximum acidic. Minus H effect increases acidity of any aromatic carboxylic acid, or you can say benzoic acid. Then comes third. Third is what? Third is CH3. Third is CCl3 that we are taking here. CCl3 is creating minus H effect. Then comes fifth. Fifth means CCl3, and CCl3 is positioned at meta position. Then comes 2 and then comes 1. Take a deeper look onto this so that we can understand how hyperconjugation can be applied to various situations, and you will be in a position to do many equations as I have discussed. That brings to an end to our discussion on hyperconjugation. Let us know a couple of things about our Altedemy platform. We have Telegram channel, and we invite you to join our Telegram channel, where you will be getting a lot of PDF materials. You will be getting free classes. You will get to know about plenty of announcements, and then some discounts and prices related to admission and other courses you will come across. So it's very valuable. Do join it immediately. You will get free classes regularly. You subscribe us, you will be getting free classes regularly as you are getting it right now. Thank you very much. Thank you very much for being with us. I hope you will be doing justice with hyperconjugation, and I hope that I have also done some kind of justice with hyperconjugation, and you will take advantage of it. Thank you very much.